a difference of 31. If I go 31 units over, that puts 2% area in the tail. If I go 31 units this way, it puts 2% in that tail. So you could calculate this by knowing this difference instead. Or you can just use it directly in Excel. And then lastly, I want to just sort of show you a shortcut, which is going to be really useful to you in life. Maybe not so much on your test or project or whatever we end up doing, but just to kind of give you a sensible feel for things that have a bell-shaped normal Gaussian distribution. Whatever the center is, let's just call it 0. Something like 2/3 of the probability, approximately, it's actually 68%, but that's about 2/3, is going to be within 1 standard deviation away. So if I have a normal distribution that's centered at 0 with a standard deviation of 1, this is a very common thing to do, is to standardize your normal distribution so that it has a mean of 0 and a standard deviation of 1. We'll talk about that in the next session. But the basic idea is that for this particular normal curve, you can know quickly that within 1 standard deviation, that's about 2/3 of the area or probability. And so for any normal distribution, 1 standard deviation away from 0 or from the mean will give you about 2/3 of the probability. If you want to go a little further, go out to 2 plus 2 and minus 2. Within 2 standard deviations, that's about 95%. That's about 19 out of 20. That is, the probability of being within 2 standard deviations of the mean is about 95%. So most of the time, 19 out of 20 times, a normal random variable is within 2 standard deviations of its mean. And then just in case you need to be really sure, within 3 standard deviations, that's going to be 0.9973 or so. Or if you want, just to be careful, to be approximate, since we're just roughing things, that's about 399 out of 400. Only once out of 400 times will a normal distribution, a normal random variable, fall more than 3 standard deviations away from its mean. So when you see something which should be normally distributed, then the chance of it being more than 3 standard deviations away is very small. I was listening to Bloomberg Financial News during the Lehman Brothers collapse and all of the madness going on 2 years ago, and the commentator kept saying things like, that's a 4 standard deviation move in the LIBOR overnight bank lending rate. That is, day to day, the rate that banks charge each other for one-day loans has a mean, and it has a standard deviation, whatever those might be. And if there's a bell-shaped Gaussian distribution to that distribution, to the change, where the change from yesterday to today is usually pretty small, if you get a 4 standard deviation jump in the overnight bank lending rate, that's a bizarrely rare and unusual phenomenon. 1 out of every 400 times will you be even more than 3 standard deviations away. So when people start talking about a 4 standard deviation jump or change or result of any kind, then you know they're talking about a very rare thing, maybe once a year, maybe once a decade, once in a lifetime, if it's 5 or 7 standard deviations away. These are things that tend to not happen with very much frequency, as you can imagine. So that's the basis of the normal distribution. We use it to describe a number of actual phenomena. There are an incredible number of different circumstances where this probability distribution will appear. And so describing physical traits or workers' habits or overnight bank lending rate changes, this type of pattern, this bell-shaped Gaussian distribution, just keeps coming up over and over and over and over and over again. So we'll start with this as our first continuous distribution, and we'll use Excel to do all of the calculations for us. Excel will tell you things like the probability of being more than 4 standard deviations away or within 3 standard deviations away. The tools that we have in Excel, again, are norm, dist, and so far we've also looked at norm, inv. And then there's a bunch of parameters it's asking for. If you want to be lazy, like some people, I don't know who you know who's lazy, then there's a shortcut if you're looking at the standard normal, the one that has a mean of 0 and a standard deviation of 1. And that's norm dist. And then it knows the standard deviation and the mean already, so it's just asking you for one value. There's also a cousin of that, norm inv. Inv. And then it'll ask you for the probability. So you can do either of these for any normal distribution with any mean and any standard deviation you want. And you can use these for the special normal distribution, the one that has a mean of 0 and a standard deviation of 1. And between those, this is sort of, it's an extra one, you don't need it, but it's faster when you do need it. So I don't know how your brain works. You might prefer to know more functions that can sometimes be quicker, or just fewer functions that will always work even when they're not efficient. All right, so that's our, I think our first session on the normal distribution. I'll focus this camera on my laptop in a minute, and we can use that to look at how operationally to use Excel to do the type of calculation we just did here on this whiteboard. All right.